Hello students, let's read this question. Mr. Smith sold tickets for a basketball game held at his high school. The tickets have a cost of $8 each. Which of the following does not represent a relationship between the number of tickets sold and his cost? Okay, so let's use the strategy of cubes to do problem solving, and we're gonna get started by identifying important information. In my first sentence, I don't find any math related content. On the second sentence, this is important. Tickets, the tickets cost $8 each. Great. Now I'm gonna look at the second sentence. Which of the following, which does not represent the relationship between the number of tickets and their cost? So far we underline, and that could be circle too. Now we're gonna box a question, and we already have the important information for the question in bright green. So we're gonna just box these words. Another thing that is very important is to look at the choices. If we look at choice A, we see they have an equation. On choice B, we have a table. On choice C, they have a math sentence. And on choice D, they have a graph. So looks like we can come up with an equation. So from the paragraph that is given, I can bring down the important information and write the equation. Then from that equation that we create, we can see if the table and the sentence and the graph are matching with the equation we generated. So that's gonna be the strategy that I'm gonna do for elaborate. So I'm gonna pause the video so I can bring those sentences for you. So I wrote a sentence that has the most important information in here. And something that is very important is that the cost is $8 each. And we always make this question. Each sometimes can be division and other times can be multiplication. It depends on the content of the question. So in this particular question, let's think about it. If we have one ticket, how much do we pay? Great, $8. What about if we need two tickets? How much are we gonna pay? $16. Great. What about if we need three tickets? We will have to repeat A one time, two times, three times. So you see, in this situation, the word each really means what? Multiplication. Excellent. And this is a multiplication x. Okay, now I'm going to look at choice A anyway, because that's going to help me to see how I'm going to do my equation. So here what they said is the cost equal AT, where C is the total cost. I'm going to be using this yellow. C is the total cost of tickets sold, and T, I'm going to use blue now, and T is the number of tickets sold, of course. Okay, so then that means that to find the total C, this is the C, and the number of tickets we said is going to be A. And it does match with the sentence because we realize that the number of tickets times 8 is going to help us to find the total. So this is our equation. This equation is totally correct. So I'm going to write it on the side. The equation that we need here is tickets equals $8 times the number of tickets, and for number of tickets they're using the variable T. And here they actually using the variable C. I'm getting the information for the choice A, and I'm making sure that it matches with the sentence that I got from the paragraph. Okay, great. And this is gonna be yellow, and the number of tickets is gonna be blue. And it makes perfect sense because remember we mentioned, okay, this is the total cost now. And the letter T represents the number of tickets. Remember when we were in elementary, guys? We used to have an empty box next to a number to indicate an operation. And now in middle school, we use variables. And it totally makes sense. If we have one ticket, instead of T, we plug in the number 1, and that will be the total cost, A times 1. What about if we have 2 tickets? Instead of this letter T, we will plug in a number 2, and that will give me the total cost. In this case, that will be 16. You see how this equation makes sense? So then looks like choice A does represent. It does represent, so this is okay. But we're not looking for something that represents the situation, but for something that does not represent the situation. So far here, that will be letter A. Now we're going to look at choice B. And in the table, I'm going to identify the colors that I use on the equation. For the total cost, you see that the letter C, we use the yellow color. So that's going to be the section on the right side, because here says C. And for the number of tickets, we use the blue, and that in the table comes on the left side. So now what we're going to do is we're going to do substitution. So we're going to write the equation that we generated on choice A. Total cost equal A that multiplies the number of tickets. Knowing that on the number of tickets, I have to use the information that is in blue. And for the total cost, I must get the number that is on the yellow side. So let's do the first one. On the first row, we're gonna focus on just one row at a time. So far I'm gonna focus on this one. You see, guys? Great. So the total cost of 16, and I'm gonna plug in a 16, must be equal to 8 times, and here we have a number 2. And 16 is the same as 8 times 2, because 8 times 2 equals 16. Great. So now we should be checking the other values, and they should be working. On the second row, we have the total cost of 64. And that must be equals to, let's look at row number 2, guys. 64 must be equals to, we have 8 times 8. And this works. This one works because 8 times 8 is 64. I'm just going to leave it indicated. Now let's look at the next one. The next one reads 96 equals 8 times 12. These numbers here, I'm getting these numbers from the yellow side on the table, and the other numbers in here, we're getting them from the blue section on the table. Great, so let's do the multiplication. Can you help me to multiply? On the side, I'm going to multiply this 12 times 8. 8 times 2, 16. 6 and we carry 1. 8 times 1, 8 plus 1, 96. So it is working. This one works too. And we just have one more to go. And on this one, we're going to have 144 equals 8, because 8 is a constant from the equation. You see here is a constant. And the variable, we get it from the left side of the table that we highlighted in blue. And the next number is an 18. This is from the blue side, like on the equation. And the total, we got it from the yellow side, in this case, 144. And I just fixed the number. This must be 184. So can you help me to multiply? We're going to multiply on the side. 18 times 8. 8 times 8, 64. 4 and we carry 6. 8 times 1, 8. 8 plus 6, 14. So it does work. So the table also represents the relationship. So, okay, so we cannot choose B. This is for choice B. Now let's look at letter C. Letter C reads, Mr. Smith obtained $260 for the sale of 30 tickets. So let's check this. He obtained 260. Looks like this is the total cost that he got for the tickets. And the number of tickets in this situation is 30 tickets. So let's use this information in our equation. And letter C, I added this squiggle so we can know that this is the information for the next choice. Okay, so the equation that we have is C equals 8. This is our constant, and this is the variable. And we know the total cost on the table, it was labeled on the very top as the letter C. That's why we highlighted that in blue and yellow. And then the number of tickets, we did it in blue. It goes like this. Now for letter C, they said that the total cost is 260. Where do we place this 260, guys? Is this 260 the total cost? Totally right. So this should be the 260 here. That should be the value that we get when we multiply A times, and the number of tickets in this situation is 30. So what happens if I multiply A times 30? Let's multiply by, I like this multiplication because the last digit is a 0. This is a multiple of 10. So one way to multiply is multiply the number that are different than 0, in this case 8 times 3, and that's a 24. And since we know that the value is more than 3, we add the 0 at the end, 240. And then the point here is this value the same as this value in here? And the answer is nope. So choice C does not represent our solution. So looks like we got our answer already, but do we have to check the graph also? Yes, we also have to check the graph. So I'm gonna come to my graph and check the values in here. For the first point, they have, when I have 2 tickets, this should be blue. You see, this number of tickets we know in the equation is what we have in blue right here. And the total cost will be the values that we have here. How do I know that? Because I read my label here, and I read my label right here. And then I just can match this information with the equation that we generated on step A. So for this point right here, I will have to multiply A times 2. You see, because there are 2 tickets and we always multiply by 8 based on the equation. So the total cost should be 16. And that's reasonable. 2 times 8 is 16, and on the graph 16 is lower than 20. That's why it is reasonable. Now let's check for 4 tickets. For 4 tickets we will have to multiply this value by 8, remember? Because that's the equation that we have. So 8 times 4, that will be 32. And 32 is below 40, so it is reasonable. Let's check this value here. We have 6 tickets here, and we will have to multiply this value by 8. And 6 times 8 is 48. Great. We will have 6 times 8. This will be a 48. And sounds reasonable because this number here should be a 50 because it's between 40 and 60. You see that, guys? Okay, so let's check on the next one. We have 8 tickets. 8 times 8, 64. And this number here appears on top of 60s, indicating it's greater than 60. And that makes totally sense. And then finally, we have for 10 tickets. And for 10 tickets, we can multiply this number here by 8 because that's the number we have in the equation. And so 10 times 8, that makes an 80. And that's exactly the value that we have here. You see that, guys? Great. So definitely our answer is gonna be letter C. Awesome, guys. Thank you.